Hello student, I am Dr. Kavita from MBA department. Today we will do a new topic, that is normal distribution. As you all know, there are two types of frequency distribution. First is observed frequency distribution, second is theoretical distribution. In theoretical distribution we have two kind of distribution. First is continuous distribution and second is discrete distribution. Today we will do continuous probability distribution, and in this we will do normal distribution. Normal distribution is very important concept, and we will do binomial distribution and Poisson distribution in our next classes. So let us start with normal distribution first. Okay. So normal distribution, what is normal distribution and by whom it is given? So normal distribution first given by Abraham de Moivre in 1733, and after that it is rediscovered by Laplace and Carl Gauss, and that is why this is also known as Gaussian distribution. Its another name is Gaussian distribution. And why there is need to study normal distribution? To study the behavior, to know the behavior of some continuous variable, like if you want to study about the height, about the weight, about the intelligence, etc., you can use this probability distribution. Now used for, why it is used for continuous variable, as you can see, and then a normal distribution as a limiting factor of binomial distribution. We have three kind of distribution in theoretical distribution: binomial distribution, Poisson distribution and normal distribution. Normal distribution can be used as limiting factor of binomial distribution if two conditions are fulfilled. Condition first is number one, n the number of trial is infinitely large, i.e. n is infinite. Means if your number of trial in binomial distribution increased, then it comes to normal distribution, it resembles normal distribution. Then neither p and nor q is very small. What is p? P is the probability of success of any event and q is the probability of failure of any event. If the value of p or q is not very small, then in case of binomial distribution we can apply normal distribution as well. Then definition. What is the definition of normal distribution? See the definition of normal distribution, where probability of x is equal to 1 divided by standard deviation under root 2 pi into e power minus 1 by 2 into x minus x bar divided by standard deviation power 2. Here, what is x bar? You all know what is x bar. X bar is mean. What is sigma? This is the symbol of sigma. This is known as standard deviation, right? Standard deviation is a measure of dispersion, and mean is measure of central tendency. We have already done in our previous lectures, so you can see those lecture also. And what is pi? You know, this is a mathematical concept. The value of pi is 22 divided by 7, and after calculating we can write it like 3.1415, and e is base of natural logarithm, and value of e will be 2.7183. Today we will do only theoretical part of normal distribution, right? So graph of normal distribution is also called normal curve, right? So and it is of bell shaped. You can see the shape of this graph is bell shaped, like bell in temple, right? So graph of normal curve is bell shaped, and its shape it depend on two values: mean and standard deviation. The value of mean and standard deviation determine the shape of normal distribution, because normal distribution can have three type of shape: mesocortic, leptocortic and simple normal. Then assumption. There are certain assumption when you are going to do normal distribution. First one is independent causes. Here the forces affecting the event must be independent of one another, i.e. they are independent of each other, means one cause doesn't depend on other cause, they should be independent. Second, condition of symmetry. The operation of causal forces must be such that the deviation from mean on either side is equal, right? Either side is equal in the number and size. There should be symmetry in case of normal distribution. Then third point is, third assumption is multiple causation. The causal forces must be numerous and of approximately equal weight of or importance. There should be number of causes for any event. Then come to the main part, that is characteristics of normal distribution. As you know, normal distribution is very important distribution and it is widely used in stat and it's widely used in research. Then there are some characteristics of normal distribution. We will do one by one. First characteristics is perfectly symmetrical and bell shaped. As in last slide we have already done the shape. This is your shape. This is the shape of normal distribution is bell shaped. So it's about shape. So first characteristic is perfectly symmetrical and bell shaped. Our normal distribution is perfectly symmetrical. If we make two parts of it, one part will cover the second part exactly, right? And then like this, this is our normal distribution, and if we half this and we cover this part with this, it will cover properly, means here 50% area is covered by this part and 50% area is covered by this part. So this is symmetrical. Second, unimodal distribution means there is only one mode. What is mode? As you know, this is the measure of central tendency. We have three kind of measure of central tendency. Main, first arithmetic mean, second median, and third mode. So in normal distribution, remember there is only one mode. So unimodal distribution, only one mode is there in case of normal distribution. Third characteristics is x bar is equal to m is equal to z. As you all know, what is x bar? Mean is equal to median is equal to mode. X bar is used for mean, m is used for median, and z is used for mode. And in this distribution, x bar is equal to median, median is equal to mode, means all three value are same. Then it is also very important characteristics of normal distribution, as you can see, asymptotic to baseline, means it never touch baseline. It seems like that it will touch, but it will never touch baseline. It is the basic characteristics of normal distribution. Then come to fifth point, range. What is the range? What is the value? What will be the value of? Like in case of simple probability, if we talk about probability, the value of probability is 1, right? But in case of you can say what is the range? In case of range of value of normal distribution, that will be minus infinity to plus infinity. You never know what will be the last value. It will minus infinity to plus infinity. Then total area under the curve. What is the total area? What is the value of this total area? The total area is 1 under the curve, the value of total area. Then mean ordinate. What is mean ordinate? It divide the whole area into two equal part. Suppose this is your, this is your mean. Mean ordinate will divide your normal distribution into two part, 50% left side, 50% right side of the curve, right. Then come to next point, point number 8, equidistance of quartile. As you know, quartile is a partition value. In quartile, what we do in quartile, we divide the data series into 4 equal parts. Suppose this is your data series. In median we divide the series into 2 equal parts, but quartile divide the series into 4 equal parts, right. So this is your Q2, this is your Q1, this is your Q3, and if we are talking about median divide that data series only in 2 parts. This is your median, right, and median is equal to Q2, always remember, right. So it divide in 2 parts, 50% and 50%. In case of median, and quartile divide 25%, 25%, 1/4 each, right. So there is equidistance between the quartile, like you can prove this by this. Q3 minus M will be equal to M minus Q1. Quartile 3 minus median is equal to median minus Q1 quartile 1. So now come to next point, that is 9 point, quartile deviation. If you want to know quartile deviation, there is a relationship between standard deviation and quartile deviation. What is the relationship? Quartile deviation is equal to 2/3 of standard deviation, always, in case of normal distribution. Means the value of quartile deviation will be 2/3 of standard deviation given in normal distribution. Then mean deviation. Mean deviation is 4/5 of standard deviation in case of normal distribution. Then point number 11 is, as we already discussed, normal distribution is a continuous probability distribution. This is also one of the characteristics of normal distribution. Now constant. There are some constant in normal distribution. Main constants are mean. Mean is that is a measure of central tendency, and you can denote mean by x bar or mu or m, right. So x bar, actually we denote x bar in case of samples mean, and we denote this symbol that is pronounced as mu in case of population mean, and m is a parameter in case of binomial distribution and Poisson distribution, and in normal distribution also. And SD, standard deviation, it is denoted by sigma. This is the symbol which is used for standard deviation, and variance, sigma square, this is the symbol that is used for variance. Now two more constant of moment, coefficient of moment, coefficient of skewness. So this is, the symbol is under root beta 1 is equal to 0. Is equal to 0. And last, moment coefficient of kurtosis. Kurtosis and skewness are also some other concept in probability distribution and in statistics, which are discussed in different lecture. So beta 2 is equal to 3. What is skewness? Skewness is basically the slope, you can say this is the skewness. There is no skewness because area under the curve is divided into 2 equal parts. Skewness if we want to know the concept of skewness very briefly, skewness means inclination of the curve one side, where distribution is not equal. Okay, now kurtosis. Kurtosis is about the height of the distribution. Leptokurtic, mesokurtic, platokurtic. This is lepto, this is meso, right? This is lepto, this is meso, and this is platokurtic, like this. This is related to height. Kurtosis is related to height of normal distribution curve, and skewness is related to how distribution is skewed one side. Then as we already discussed, shape and then main parameter. Next characteristic is main parameters. There are main parameter, mean and standard deviation. Next point is okay, this is for today. Next we will do in next class.